Right, so here I have the implementation for the USART task 1, where you just send a message over the UART and ask the user to input a value into the terminal, and then the same value that you press, the same button, the ASCII character of that will be sent back over the terminal. So here in my setup I've got a power supply. This is 5-volt supply, and I have a oscilloscope here which is connected to the RX pin of the microcontroller, which is on this board. And I have this converter here. So this is a USB to serial converter. So this allows me to take any serial data from the chip, convert it, and then have it transmitted over USB to a computer. So this is my computer. I have a terminal running, and I've already received some messages. So let's just reset the system. So we're going to press the reset button, and that will reset the program. So there we got the prompt, and now when I press a button on my keyboard, it will be captured by the scope. And to do this, I will, because I don't have enough hands, I'll just use the single capture. So it will just save whatever's on screen as soon as the signal is sent. So I'm gonna press L. Okay, it's out of the screen, so I need to adjust it a bit. Need to go. So let's just keep trying. Okay, so single, and then L. Okay, so there's a signal. So now that we've captured it, we can manipulate it, just like in Proteus. We can make it bigger. We can also expand it horizontally if needed. So the horizontal knob is here. So I think this is the best option we have currently in terms of time. And just like in Proteus, we want to align it to a vertical line, and then we'll see that the time base is 100 microseconds, or as in Proteus was showing 0.1 milliseconds, which is exactly 100 microseconds. So you see that it's the same speed, just like in Proteus, and this would mean that each box horizontally, will be 100 microseconds, while each box vertically will be 2 volts each. And I can change that if I want to. I just made it bigger by changing this to 2 volts. And this is L. So as we said before, if we use, for example, we could use the cursors, and then we could measure if we didn't know, because it's really difficult to determine how long is one bit using this picture right here. So let's try to use the cursors instead. So we know that it should be 100 microseconds each, and we could see here the difference between the cursors is roughly that. So we can tweak the fine adjustment there, so we can make it exactly. So this is exactly 1 bit. We know that we have the first bit of the communication is always going to be the start bit. So this is going to be the start bit, and then we can see that we have approximately, so we can see that 100 microseconds is exactly 1 box. So we can assume that this is bit 0, this is bit 1, bit 2, bit 3. So we have 0, 0, 1, 1, and then we have a 0, 1, 1, and another 0. So we have 4 ones and 5 zeros, and then we have the stop bit with the parity as well. I believe that in my settings on the terminal I've disabled the parity, so it's not there. That's why the transmission looks like this. I think on my terminal on the computer, when I was setting it up, I did not enable parity, so it's probably why we have 1 bit less in the communication. But this is it. So we have 0, 0, 1, 1, 0, 1, 1, 0. And you know this is the least significant bit, so we have to flip the data to get the actual number. So that's gonna be 0110, which is 6, so that's 6, and then we have 1100, which is 12, I think. It should be D in binary, in hex. Yeah, so that's D. So that's D6. So let's have a quick search for ASCII table, just to make sure that we have everything ready and correct. So I have an ASCII table open, and for 6D we have 6D, so these are the most significant bits, so this will be flipped. So we have 6 should be like this, so it should be 6D, and 6D is let me just check. Oh, sorry, it's not D, it's C. This is C. This is C, it's not D. So we have 6C, which is L. This is L in ASCII, which is exactly what I have sent last, right there. So this is how you can communicate between a PIC and a computer using serial terminal and serial communication.